Hello everyone, my name is Abdul Aziz Iqbal. I'm a student ID is 2025-3-2001. So today I'm going to explain my structured data lab report. So just this report is mainly about binary tree and binary search tree. So let's just dig in. So first one, the struct node definition. Before looking at the functions, we need to understand our building blocks, the node struct. Each node contains three components. First, integer data, and then pointer name left and right. And then function one, we have create tree. The first operation is create tree. This function initializes a brand new empty binary tree. It simply sets our global root pointer to null pointer here. This tells the program that the tree doesn't have any nodes yet. And then the second one, we have empty tree. This is a utility function that returns a Boolean value true or false. It checks whether the root is equal to null pointer. If it is, the tree is empty. This check is crucial to do before running other operation to avoid errors. And then we have function number three, highlight insert node and insert tree function. So for adding some data, we have to make a function named insert tree. It utilizes a helper function called insert node, which work recursively. So the logic is if the current position is empty, it dynamically allocates the new node and places the value there. If the value we want to insert is smaller than the current node's data, the function calls itself recursively to move down to the left subtree. And then if the value is larger, it moves to the right subtree. This systematic sorting ensures that our tree always maintains the proper binary search tree structure. And then we have delete tree and delete node. Deleting a node is a bit more complex because delete tree has to handle three distinct scenarios. So case one is if the target node is a leaf, it has no children, we can just free up its memory safely. And then case two is if the node has exactly one child, what we bypass the node and connect the child directly to the parent node. And then last, if the node has two children, we can just delete. We cannot just delete it arbitrarily. We have to find its in order successor, which is the smallest value in its right subtree. We copy that successor's value to the target node and then recursively delete the duplicate successor node. And then we have info and search node. Uh, This function is great for debugging. First is uses search node to find a specific value recursively based on BSD rules. Once found, it prints out the node's own data along with the data of itself, child and right child. If a child doesn't exist, it simply outputs null or nil. Lastly, we have traversal method. Let's look at how to traverse or visit every single node in the tree. So my program implements 4 different methods: pre-order, in-order, post-order, and level order. And lastly, the show menu, the main. In the main function, all these options are typed into an interactive menu loop based on my task cases. Inserting and deleting values update the traversals instantly and correctly. So we can test it by running. We have menu. We can make a tree first. A new tree have been made. So we can input some, sorry, we can 1, 3, then we 20, and then 3 again, 40, 3 again, 50, 3 again, 60, 3 again, lastly 66. And then we can see what the info look like. 30. There's no 30. And then we can see the whole pre pre-order and the rest. So this is the ending result. We can see. That's all from me. Wassalamualaikum warahmatullahi wabarakatuh.